Welcome.
Thank you for this opportunity.
Well, first of all, what exactly is Seafarer? Because I would venture a guess that most Canadians are unaware of what you're doing.
I think that's true. Seafarer stands for the Canadian Institute for Advanced Research. And I think what we do is kind of unique and kind of important. We identify really important questions and exciting questions facing humanity in the world, and we also identify some of Canada's best minds and the world's best minds, and we bring them together in sustained and deep conversations about trying to address those complex and important issues.
So why is it important that you have a global reach? What is it about that an organization like Seafarer can address that individual countries can't?
I think that global reach is important for a lot of reasons. First, a lot of the problems that the world faces, of course, are not unique to any one country. If you think about global warming, the polar ice cap, terrorism, interesting scientific questions like the relationship between brain and mind, identifying sustainable forms of energy, cancer. These are not unique to any one country. They're global issues, and so they need to be addressed in a global way. That's one reason. Secondly, we're a small country. We're about 5% of the world's scientific literature. And so if we really want to get together the world's best minds, at most we'd expect 5 to 10% of the world's best minds to be in Canada. The third reason is I think it really strengthens Canadian research and Canadian universities by placing Canada's best in the same room as the world's best. They really get to know each other. They're in deep conversations over a 5, 10, 15-year period. And so they get to know each other. Their trainees get to know each other. And so it's good for Canada for us to be out there and for our best minds to be interacting with the world's best minds.
Science and technology are incredibly complex today, and as Carl Sagan had once pointed out, we live in a world that is utterly and totally dependent on science and technology, and yet we've constructed a society where virtually no one understands science and technology. Yeah. What does Seafarer do to help us at least know that we're in good hands? Because I don't know that we can say to somebody, oh, and here's how it works. Like literally you have to say, trust us, we know what we're doing.
Yeah, I think that's a general problem for the scientific and research community more broadly, how to communicate results and engage the public, not just communicate, but engage the public. And I think, of course, it also relates to how we actually teach science in schools. That is a learning opportunity. And so we've been talking a lot about how do we change that conversation. When I went to school, which is a few years ago now, science was taught as a series of facts. Parts of a flower, parts of a frog. And it's actually anything but. Science is a process. It's a powerful way of looking at and understanding the world around us. And so we need to engage that sense of wonder and excitement in the public because it is important, as you're implying, that the public not just receive the benefits of science, but actually understand the process.
Can you explain to me exactly what the role of science is? Is it to explain the world as we know it, or is it to also play a predictive role?
That's a good question. I think the first thing is to understand the world, and both the human world and the natural world, the biological world. And understanding implies you can predict. I was watching my little granddaughter on a beach in New Zealand picking up rocks on the beach. And under one rock, she found 2 crabs. She was very excited, as you might imagine. She's 5 years old. So she spent the next hour looking under rocks because she was making a prediction that if I found them under one rock, there must be more under other rocks. She was being a scientist.
Was she successful in finding?
Yeah, she found one other rock and it was enough to keep her engaged for an hour. She found one other rock, but I think that's really, prediction is part of testing an idea. If you think you really understand something, then make a prediction in a different kind of circumstance and see if that prediction comes true or not. So that's an important part of science. Of course, I think equally important is out of that understanding of research and science has come amazing number of benefits for humanity. We live in a world that's been transformed by science, from electricity to iPhones to vaccines, and I could go on, of course. The world is just totally different because of science.
And that's because we understand the way that things work.
And exactly.
And then we can build upon that.
And we can build upon that. And that's an interesting thing, that from understanding comes, that building. Almost always, it's a kind of curious thing. It's not obvious, but that's what happens. And so I think we take for granted, it's human nature, the progress that's happened over the last little while. But it's not that long ago that we couldn't fly.
No, it's not very long ago at all.
We take that for granted. Canadians have extended their lifespan by 3 years every decade for the last 100 years. So the average Canadian born today will live to about 81.
It's the average Canadian.
The average Canadian.
Yeah.
Not that long ago, the average Canadian lived to 65. And it's not only that we're living longer, we're living healthier. And that's not by accident. That's by research. And indeed, much of that early research back in the 80s when Seafarer first started came out of one of our very first programs called Population Health. It was led by Bob Evans, an economist at the University of British Columbia here in Vancouver. And that group of researchers kind of focused on the socioeconomic determinants of health. And they drew attention to the issues of, it's not just viruses or heart disease that causes illness. It's our socioeconomic status and whether we exercise or not, and all those lifestyle things.
Okay, let's go back 30 years ago. Where did the germ of the idea for Seafarer come from?
Yeah, so it's interesting. The history of Seafarer, it started at the University of Toronto. And there was a discussion started about how to strengthen the social sciences and humanities at the University of Toronto. And as a result of that kind of discussion, it quickly broadened to why stop at social sciences and humanities, and why stop at Canada? Why stop at University of Toronto? Why stop at Canada? Let's embrace the world. And so CIAR, as it was called then, quickly kind of evolved to taking on and engaging the world and really connecting the most extraordinary minds in the world on any topic. What we do is something that most other institutions find it very difficult to do. We bring together people from very interdisciplinary backgrounds.
I know that in reading your material that you stress this, that there needs to be this interdisciplinary approach. And why is that so fundamentally important?
Yeah. Because it's quite simple. The most interesting questions don't conveniently lie along disciplinary boundaries. They don't respect them. And why would we expect them to? And so I'll give you a couple of examples of new Seafarer programs that were just in the startup phase of starting up. One is around sustainable forms of energy. It's called bio-inspired solar energy. Nature has figured out over hundreds of millions of years of evolution how to harness energy from the sun very efficiently, very effectively. It's called photosynthesis.
Right.
It's way better than what we've come up with as a species. And so can we marry what nature has done so well by really identifying the best biologists in the world who are doing photosynthesis research with people who understand material science, so physicists and chemists, engineers? Can we bring these groups together, groups that would never talk to each other, actually don't even know how to talk to each other? They speak completely different languages. And can we put them in the same room, and over time they will learn to talk to each other if they're interested in the problem, and they will benefit themselves, and the world will benefit if they can somehow harness what nature's figured out what to do.
But how do you get to them? How do you identify them? How do you bring them together?
It's circles within circles. So we look at the literature, we decide what kind of fields we want, we identify senior people as advisors in an area, and then we do a lot of talking to around the world about who's the best person doing photosynthesis research these days, in your judgment. And we do a lot of that talent scouting
So you reach out to them?
We reach out, oh yeah, absolutely. You don't apply. You're tapped on the shoulder and said, would you like to join our program and become a Seafarer Fellow?
And you are funding programs. How many programs are you funding at the moment?
At the moment, we have 14 programs, and they range from social interactions, identity and well-being. It's a behavioral economics, psychology, social science group, to genetics, it's called genetic networks, to child and brain development, to neurocomputation and adaptive perception. That's our machine learning, artificial intelligence group. And a few others, obviously, that I haven't mentioned. So we're not bounded by geography. We're not bounded by discipline. We're not bounded by problem. We take on what we think are really, really important and exciting questions.
So you're reaching out beyond the Canadian landscape to create this virtual network. Because
Exactly.
It's not like you have a campus.
We have no campus. We are a virtual, in a sense, a virtual university.
Is any other country, or are there any other organizations similar to Seafarer, or are we setting the way?
Yeah, so there are a couple of organizations that sort of come close, but no, there's no other organization that I know of, and I've looked pretty hard, and so have others, of course, that does what we do. We have had a few conversations with people in other countries who would like to sort of clone Seafarer in their own country. And so we're talking with them about either helping them, or could we collaborate or partner with them and do something together. But yeah, there's no other organization that does what we do, and which is interesting because most national funding bodies are exactly what I just said. They're national. And yet many times, of course, the issues and the people who you'd like to engage in a team happen to be in a different country, especially if you lie outside one of the major scientific powerhouses of this world, outside of the US or the UK, for example. And so it is a natural thing to think about, why don't we bring people together to talk about these global issues?
But don't most countries look at that kind of scientific research as being a bit of a national treasure, and they don't want to share it because they're thinking about it in the perspective of their own economic development? If we develop this and that technology stays here, we'll get the economic benefit of keeping it here. Why do we have this vision that says, no, we're going to be inclusive?
Yeah, so I think that's partly a Canadian thing.
Yeah.
Maybe it's influenced by our geography. We live next door to the United States, and so we're used to looking at another country. If you talk to the research community, they will tell you increasingly that research knows no boundaries. And that they need to be able to engage and collaborate with the people they want to talk with and work with, regardless of where they are and regardless of discipline. And that's been a trend that's becoming more and more evident over the last 10 or 20 years. So I think the research community is kind of there. And remember, the ideas, of course, know no national boundaries. Once you come up with a new idea and tell people about it, it's instantaneous. The world knows about it. The ideas flow freely. There's no trade barriers. It's all about both collaboration and competition at the same time. And so our group's, a typical Seafarer program has about 20 top researchers in it. We judge that program on the basis of how well are these 20 people really interacting with each other, even though we know that some of them are, in a sense, competitors. So we want both collaboration, and we understand that research is always also about competition. You can only be first once.
What is the direct benefit to Canada then, if I'm kind of staying within that economic model? If somebody said, well, okay, we're doing all this and it goes out to the world, but even if we could say, well, it's here, you're saying, well, we're going to be out to the world to begin with. How does Canada get a direct benefit out of being the instigator of this kind of program?
So I think Canada benefits in a whole lot of ways. One is what I've already mentioned, that I think that Seafarer, by placing Canadians in the same room with the world's best, really strengthens Canadian scholarship and science. And so that strengthens our universities, it strengthens our education. And so we have a huge investment in higher education and research going on in our universities. And Seafarer's sort of cost is sort of incremental to that. That's number one. Number two, it's a wonderful recruiting tool. So over the years, I think Seafarer, because of Seafarer, Canadian universities have been able to recruit some of the world's best researchers because they got familiar with Canada, they got familiar with our research community, and they came to Canada for meetings because of Seafarer. And so I know of many stories, even in the short time that I've been president, of really top people who have come here because of Seafarer. Third, there's been economic spin-off, economic benefits. So for example, here in Vancouver, there's a company called D-Wave, which is trying to build a quantum computer. The origins of D-Wave came out of a conversation between two young scientists at a Seafarer meeting a number of years ago now in quantum materials. And so these guys met because of Seafarer, and they were within an atmosphere of thinking big, thinking out of the box about what would be possible.
So you say as a researcher, you don't apply, you get invited. But
Right.
young researchers may watch this at some point and go, okay, but how do I get onto the radar screen? How do I make sure that you know what I'm doing so that you can consider my work for the
That's
future?
an excellent question. And we're very aware and sensitive to that issue because it is important that we identify the brightest young stars in the next generation. Science and research is about young people because it's about change. A lot of our programs will allow each fellow to bring one trainee or one young person to the meeting with them. So that's one way we get a look. Second way is we have a Global Scholars Program, which is part of a sort of a larger initiative called the Global Academy, where we identify young people either as a postdoctoral fellow or now as a beginning assistant professor who are just at the beginning stages of their career. So we actively go out and look for these people and we attach them to one of our programs.
What does the future look like for scientific research in Canada on its own and as a result of this global interaction that you're helping to create or facilitate?
Yeah, well, I'll just say that, first of all, I think we live at an amazingly exciting time if you do research. It's like being a kid in a candy shop. The technologies, and whether it's computers or telescopes or gene chips, are so powerful that you can ask powerful questions. And this is just the greatest time ever to be in science and to do research more broadly. That's the first thing. I think Canada is a great country to live in. We have the ability to attract the world's best here. So I think for Canadian science and research, it is about people. Our natural resource in research is people. And we have the ability to attract really great people. And the federal government and increasingly provincial governments have invested over the last 10 or 15 years very heavily in university research. The amount of investment in research in this country compared to when I started in research is a sea change.
Let's say somebody's watching and they go, I want to be able to help. What do they do? How do they get involved?
Well, there's lots of ways you can help. The obvious way is to donate money. And we get our funds at the moment about 1/3 from the federal government, who very generously supports us, 1/3 from 4 provinces, Quebec, Ontario, Alberta, and British Columbia, and 1/3 from individuals, corporations and foundations, and increasingly from partnerships with organizations around the world. That's a new initiative for us. And so people can help both by donating, but also, I think, by becoming engaged.
How do we, as people who live outside of the scientific community, know that we can trust the research, even if it's contrary to what our own worldview is?
Yeah, that's a really great question. It needs a long answer. I think the short version is, I think the public has a view that science is a collection of facts. And if there's anybody that disagrees with the facts within even the research community, the public decides, come back when you know the facts and don't bother me until that. And that's really not how research works. Research is a kind of a messy process of trying to understand the complex world we live in. And gradually, the research community will reach a consensus view as to what, in quotes, the truth is. And so I think for the public, the best way to kind of make your own minds up is to, if it's a question that matters to you, is to engage, not to listen to one researcher or go on the web because you don't know what's reliable or what isn't, but to listen to the research community as a whole. What does the community as a whole think about an area, who are experts in this field? Today, of course, the issue is global warming.
Mm-hmm. And there are divergent views there.
Well, there are some divergent views, but if you look at the consensus and if you look at the data, it's pretty clear that first, the Earth overall is getting warmer. The Earth's atmosphere is getting warmer. So that's number one. I think that's fact. The second question, more controversial, is what's causing that? Is that actually human activity? Is that the release of CO2 in the atmosphere? Or is it something else? And again, I think the bulk of the research evidence suggests that it's CO2. Now, are there people who don't agree? Yes, absolutely. Mm-hmm. But what, to me, and I'm not an atmospheric scientist, what does the bulk of the research community in that area say, people who I trust say? They would all say it's due to CO2 release into the atmosphere. And so I'll put my money on that collective wisdom. So that's my own view as essentially a layperson in that area, but I understand science, of course. So I think that's, now what's interesting to me is when, for example, vaccines. You have the scientific community, thousands of studies over 100 years now, mm-hmm. saying vaccines are safe and incredibly effective. And then every once in a while, someone will pop up and say they cause autism or some other disease. And the public tends to go here. It's an interesting phenomenon. Mm-hmm. And there's a whole lot of underlying causes of that, I think. One is these people speak louder. They're listened to by the public. They're celebrities, or they have an opposing view, and we all kind of favor the underdog. But you know, when it comes to children's health, I'd much rather go with the evidence of all of these people over here than one person who chooses to kind of take anecdotal evidence and say that, well, actually it causes autism, which is not true. And so if you look at vaccines, which I know very well, there's about 500 million lives have been saved over the last 100 years because of research done in the 19th century by Louis Pasteur and others, mm-hmm. that showed that actually diseases like polio and measles and diphtheria, et cetera, were caused by microorganisms, and you can prevent those diseases with a vaccine. I'm going to paraphrase a guy called Seymour Bernstein, no relation, there's a movie out about him. That science, I think, is evidence of humanity's perfection.
Well, Bill Gates, I believe, is on record as saying, I think science will solve all of our problems, and I hope he's right.
I hope he's right, too.
Thank you very much. Appreciate you doing this.